Hi! There's been a lot of issues with the graphing of roses, so I wanted to demonstrate you guys with one simple example, okay? Um, the key thing here is you don't need every coordinate, okay? You already know what this rose looks like. You know a couple of things. This is an even number, so you know it's going to have 4 petals, right? 4 petals because it's the even number. N is even, right? The N here, okay? In fact, this one has a lot of things that you should recognize before you even get started on this graphing. You know the period of each sine, complete sine graph is going to be 2 pi over b. In our case, it's going to be 2 pi over 2, which is going to be pi. That means that every pi, you're going to have one complete sine cycle. And you also know a couple other things, max, min, right? 5, -5, because there's no midline shift, okay? So you know what I'm going to do? I'm going to actually graph this sucker. I'm going to graph this sucker like this. Let's make it nice and big. You don't have to graph, okay? So here's my first cycle, okay? And here's my next cycle. All right, so you guys, we know a couple of things, right? We know this coordinate, we know this coordinate, this coordinate, this coordinate, this. All these are important coordinates that'll help us to graph our beautiful rose. We for sure know that it's going to be having, it's going to have 4 petals and it's going to be a rose, okay? So you guys, this is a 5 here. And this is a -5 here, right? So let's start naming our coordinates here. I'm going to actually sharpen my pencil a little bit. All right. So this guy is 0, 0, right? Obviously. Well, you know that full cycle is going to be pi, and it's also 0. You know this guy is also 2 pi 0, okay? All right, we're getting started, okay? What's half of pi? Pi over 2. So pi over 2 and 0, right? You can see that it's growing every 45 degrees or every pi over 4, if that makes it easier for you to calculate, okay? So this guy is going to be what? This guy is going to be pi over 4 and 5. What's after pi over 2? It's 3 pi over 4. 3 pi over 4, and it gives you -5, okay? And let's see what else. After pi, it's going to be 5 pi over 4, and it gives you the maximum. And after pi over 4, it's 3 pi over 2, which gives you 0. And then after that, it's 7 pi over 4, and it gives you -5. And you know what we should do? We should actually name these too. So let's call these guys A, B, C, D, okay? A, B, C, D, E, F, G, H, I, E. Okay, now we're ready to graph this sucker. Now, these might not be enough points for you to see everything, but it gives you a good idea of where it's going and which direction it's going. So just keep that in mind. I don't need you to give me every single coordinate. You got it, buddy? All right, so you guys, let's start graphing these suckers. You know what I'm gonna do, you guys? I'm gonna shift this graph up a little bit. So I'm gonna actually cut this guy, copy that sucker. I'm gonna copy it here. Okay, and I'm gonna cover that guy up. So ignore the bottom piece, okay? Because I want you to be able to see the coordinates. All right, you guys ready? Here we go. Let's start graphing, okay? So I'm gonna go A, 0, 0. So I'm gonna call that guy A, and I'm gonna call this guy A. All right, that's our A. If it's easier for you to start sketching as you go along, okay? Pi over 4 is 5. So I'm going to go pi over 4, but I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to go 5. And that's B. You're like, wait, okay, now what happened to C? Well, it goes back to 0, right? Because pi over 2, and then it goes back to 0. So wait, so it went from, just do some common sense here. It went from here to here to here. How do you think it went? Did it go from here to down? Or did it go this way? And you know it's never going to be straight. No linear connections here, right? So we know that it goes from here to here like this. And how wide it goes, I'm not going to be that critical. So don't even trip, okay? All right. Let's go to the next one. Next one is pi over 4. So next one is 3 pi over 4, right? D, right? Let's go to D. 3 pi over 4. 3 pi over 4 is here, right? I went 3 pi over 4, but it's -5. So back that ass up. Back that ass up. So it's going to be here. What the heck? All right, so that's going to be our, so let's just continue. This is our D. Let's go to E. Pi, 0, oh, wait, yeah. Yes, that's good. Okay, sorry, I'm getting confused. Pi is 0, so it goes back to here. Wait a minute. So that's D and E. How did it get there? How did this guy go from here? And how did this guy get here? If you're wondering how it went from here to here and then back to E, what you got to do is you've got to actually go ahead and plot some coordinates between, okay? All right, so D, okay. What is happening, okay? So it went from here, somewhere here. So, oh wait, we missed something, you guys. How did it go from here to here is what we have to ask. And then how did it go from, sorry, I forgot to mention this, okay? How did it go from here to here? Did it go like that or did it go like that? Because from B to C, it went this way. So you know you have to go this way first. Okay, that's the first and the second. Now, it went from A, we back to E, right? But it went from C to D and then back to E, right? That means you don't need exact coordinates, you guys. You know for sure that it went from here to here. And then it went from here to here. Put the arrows nicely so it tells you. And then 3 and 4. I don't need exact coordinates, but if you want to try some extra exact coordinates, you should, okay? All right, where are we now? We're at 5 pi over 4. So let's go pi over 4. I'm going to go 5 pi over 4. Whee! Okay, but it's actually 5. So I go 5 pi over 4, and it's 5. Do you see what happened? I went from E to here. And then where am I going to go? 5 pi over 4, G, that's F. G is 3 pi over 2. So I'm going to travel 3 pi over 2, and I go to 0. Whoa. So you guys think about it. I went from E to F, and I went back to 0. Did I go this way or this way? I want you to think about why it has to be this way. Okay? I can't tell you everything, but you can kind of think about why it has to go that way first. Because we're moving this way. Okay? So think about that. All right, let's go to the next one. So now, again, mark it. 5, 6. Woo! We got 6 leaves already. We need one more leaf. Where is it going to go? Obviously the second quadrant, but let's see what happens, okay? So let's go to 7 pi over 4. 7 pi over 4 is here, right? 7 pi, okay? But I'm going to back that ass up to 5. So I'm going to go here. That's going to be our H, right? And let's go to I. Well, I is 2 pi 0. So that means 2 pi, and it's nothing. So we go back to normal. So that's going to be our I here. Okay, so sorry about these zeros. All the zeros, I'll mark it black. 0, 0, 0, 0. So many zeros, okay? So you guys think about it. How did it go from, let's go 8. So G, where's G? G is here. Oh, I forgot to mark G, right? G is 0. So I forgot to mark a G, okay? You guys, how did it go from G to H? Did it go this way or this way? Think about it. Think about it. Okay, it could only go this way. Oh, sorry, I used the wrong color marker here. We gotta keep the, oh shoot, let me erase this. Ah! Let me erase this. Make it prettier, okay? Let's make it prettier. This is the this was the coordinate H, and then we go that way, and then we go back to 0. So it went here and here. But I want to show you something here. You think that I'm making a lot of assumptions, but I'm not. Math is great because it has this nice flow. I don't even have to pick up my pencil. Watch this, you guys. 1, 2, 3, 4, 5, 6, 7, 8. It has a nice flow every time. Okay? So again, main thing you have to remember when you're graphing roses is that you don't need every coordinate. But using your coordinates, can you make assumptions about how it's going to move? Okay? All right. Good luck. Bye.